Hello again. Today we are looking at quadratic inequalities in one variable. To solve quadratic inequalities in one variable, we need to consider some rules. Now let's quickly look at some of these rules. If A and B are factors of a quadratic trinomial, remember a quadratic trinomial is an expression such as ax squared plus bx plus c. This is a quadratic trinomial. Okay, if a and b are factors of a quadratic trinomial and if a b, that is the product of a and b, is greater than 0, then either a is greater than 0 and b is greater than 0, or we say that a is less than 0 and b is less than 0. Basically what we are saying is that for us to multiply a and b and getting a number that is greater than 0, that is a positive number. It is either that a is greater than 0, that is a positive number, and b is also greater than 0, a positive number. That is, we multiply a positive number and a positive number to get a positive number. Or we multiply a number less than 0, which is a negative number, and a number less than 0, another number less than 0, which is also a negative number. That is, we multiply a negative and a negative to get a positive number. Okay, so this satisfies this expression, this statement, that if b is greater than 0, then it's either that a is greater than 0 and b is also greater than 0, or a is less than 0 and b is also less than 0. Again, if we have an expression such that a times b is now less than 0, then either a is greater than 0 and b is less than 0, or you say a is less than 0 and b is greater than 0. That means for the product of a and b to be less than 0, that is negative. Okay, it's either a is positive and b is negative. That is, a is greater than 0 and b is less than 0, or a is less than 0 and b is greater than 0. That is, whenever you multiply a positive and a negative number, you always have a negative number, which is a number less than 0. Is that clear? So now let's consider some examples. Show graphically on number line the solution set of the following inequalities. Show graphically on a number line the solution set of the following inequalities. 1. X squared plus x minus 6 is greater than 0. 2. X squared plus 3x minus 4 is less or equal to 0. And lastly, x squared minus 2x minus 3 is greater or equal to 0. Let's consider the first one. Number 1 says x squared plus x minus 6 is greater than 0. All we need to do, just as if we are solving a quadratic equation, we need to factorize the left side of the inequality. Let's factorize the left side of the inequality. Okay, so in factorizing the left side of inequality, I will multiply the first term with the last term, that is x squared times negative 6, and that is going to give me negative 6x squared. Okay, and then I will consider factors of negative 6x squared such that when I add them together, they will give me x, which is the middle term. So when I consider 3x and 2x, negative 2x, okay, so I'm considering 3x and negative 2x, such that 3x times negative 2x will give me negative 6x squared. And when I add this together, I have 3x plus negative 2x. This will give me x, which is the middle term that I'm looking for. So what I will do is I will substitute in place of x 3x minus 2x, so that my new equation, when I write this, is now going to be x squared plus 3x minus 2x minus 6 is greater than 0. Okay, now I can factorize the left hand side. You know, when I factorize this, what is common? I bring out what is common between these two pairs, which is x, and when I bring out x, what is left will be x plus 3. And what is common between these two pairs, I also pull it out, which is minus 2, and what I will have left will be x plus 3, and all this is still greater than 0. So I collect what is outside the bracket, x minus 2, and what is left in the bracket, since they are the same, I pick one, x plus 3. This is now greater than 0. Now let us apply the rule we have learned. We still remember the rules, right? Remember, we say when a, b is greater than 0, then a is either greater than 0 and b is also greater than 0, or a is less than 0 and b is less than 0. Let's bear this in mind. Let's bear this in mind as we proceed. In this case, the first expression, x minus 2, we take to be a. And the second expression, x, the second factor, x plus 3, we take to be b. And then greater than 0. Okay? So let's apply this rule now. So in this case now, it's either x minus 2 is greater than 0 and x plus 3 is also greater than 0. And when this happens, it means that x is greater than 2 and x is greater than minus 3. Now, these two expressions can be written as one statement. Okay, we can write this as one statement. Since x is greater than 2 and x is greater than minus negative 3, it simply means that x is greater than 2. We can write this as a single statement. Okay, we have just combined the first and the second statement into one statement. Since x being greater than 2 also means that x is greater than negative 3. Now, or, remember, or x minus 2 is less than 0 and x plus 3 is less than 0 for us to get a positive number. Okay, so this means that x is less than 2 and x is also less than negative 3. Now we can also combine this into a single statement. Okay, combining this into a single statement, since x is less than 2 and x is less than 3, that means x less than 3 also means that x is less than 2. Okay, so in a single statement we can say x is less than negative 3. Okay, and say x is less than negative 3. So this is a single statement for this, and this is a combined statement for the second one. Okay, so we can represent this now on a number line. How do we do this? Let's represent this on a number line. Let's say this is our number line. Okay, this is our number line. Okay, we want to represent this on a number line. Remember, we have negative infinity and we have infinity. Negative infinity and infinity. For the first statement, for this one, I may say let this be negative 3. Okay, and let this be 2. Okay, now to represent this statement on a number line, this means x is less than negative 3, not including negative 3 itself. So we represent this with a dot, and all values that are less than x, negative 3, are values of x. On this other one, we want to represent this also on a number line. So since it is a greater than sign, not equal, greater or equal to, it means that 2 is not included in the range of values of x, and x is all values that are greater than 2. Okay, x is all values that are greater than 2. And what will be the interval notation in this case? What will be our interval notation? For this one, it's going to be negative infinity, the lowest, to negative 3. Okay, union. Remember, we made mention of union in our last video. Okay, what is the use of? So union, we say it is used to represent the joining of two sets of values, of x. So in this case, we have two sets. This is the first set, all values that are less than negative 3, and the second set, all values that are greater than 2. So 2 here is the least value, so that will be 2 comma infinity. Okay, this is how the interval notation will be represented. Okay, so number 2, we're having x plus 3x minus 4 is less or equal to 0. Again, I have to factorize the left side of the inequality, the expression, the trinomial. On the left side of the inequality, I will have to factorize. And to do that, I will multiply the first term and the last term. And that will give me negative 4x. And negative 4x, that is minus 4x squared. Okay, and I will look for the factors of this 4x squared such that when I add them together, it will give me the middle term. And these factors could be 4x, and negative x. When I multiply this, I will get negative 4x squared. And when I add it together, I'm going to get that is 4x plus